Hello, this is Mr. Win, and this video is over special segments in a triangle. So this section is all about vocabulary, so make sure you write down these definitions. The four special segments we're going to cover are 1, median, that is a line segment from a vertex to the midpoint across from it. 2, altitude, that is a line segment from a vertex that is perpendicular to the side across from it. That's also known as the height, and it couldn't be outside of a triangle. 3, angle bisector, that is a line segment from a vertex that also bisects that or cuts in half the angle at that vertex. And 4th, perpendicular bisector, that is a line from a midpoint that also is perpendicular to the side that contains that midpoint. Alright, so each of these 4 things have 2 different properties. Median has vertex, median has vertex connected to midpoint. Altitude has vertex connected with perpendicular, which is say 90 degrees. Angle bisector is only that has one, which is just a single vertex, or because angle in half. And perpendicular bisector has midpoint with perpendicular, 90. So perpendicular bisector has nothing to do with a vertex, while altitude has nothing to do with a midpoint. And then median has nothing to do with 90 degrees perpendicular. Alright, so make sure you know the 2 things that talks about each word or defines each special segment. Also, just so you know, a triangle have 3 different medians using if you use the different vertices. You can have 3 different altitudes, 3 different angle bisectors, because there's 3 different angles, of course, and then 3 different perpendicular bisectors. So let's try some problems. Name this red line. Well, this red line starts from a vertex up here, and it ends at a midpoint. We know it's midpoint because with these 2 marks right here. All right, so if you have vertex, midpoint, those 2 things define one special segment. If I go back, vertex, midpoint is the first one, median. So this is a median. All right, so you'll be able to define the term and then also do some math. If you see medians, that's involving midpoint. Midpoint, you know, side equals side. So this left side, 8x plus 9 equals this right side, 12x minus 3, because that's the middle. Basic algebra, subtract 8x, so 9 equals 4x minus 3. Add 3 both sides, 12 equals 4x. And then divide by 4, 3 equals x. Alright, next one. Name this red line. Notice red line has a vertex up here. And it doesn't go to the midpoint, but it goes to 90. Which one has vertex 90? That one is altitude. That's like the height of a triangle. All right, find G. Well, the right side is 90. The left side also be 90, because remember, this forms a linear pair. You could say linear pair, angle plus angle equals 180. You can say G plus 90 equals 180. Subtract 9 both sides, G equals 90 degrees. All right, so there's that. Name the red line. This red line starts at a vertex, does not make 90, does not go to midpoint, but look, those 2 angle marks there, this means they're the same. That means this is an angle bisector. Now it says find Z. Well, those 2 angles are the same. That's the top half of the angle, bottom half of the angle, so they're equal to each other. So 10Z minus 10 equals 7Z plus 5. You're going to subtract 7z both sides, so 3z minus 10 equals 5. Add 10 both sides. You get 15. Divide by 5. Sorry, divide 3. Saying the wrong thing. You get 5. All right, so we found z. Next one. Name this red line. This red line has nothing to do with vertex. It does involve 90, perpendicular, and involves midpoint. This is a midpoint because of those 2 marks. So which one has 90 degrees and midpoint? That is perpendicular bisector. Perpendicular means 90. So whenever you see a 90 degree angle, you should always think perpendicular. And it bisected that line, that side. Right, so find something. Oh, 3p 21. Well, those aren't each half of the midpoint. So we know they're equal. The left half equals the right half. 3p equals 21. Divided by 3, p equals 7. Alright, so those are 4 common examples of each type. Now we're going to do the reverse. Instead of naming the line, they'll tell us the line, we have to figure out and solve or find something. So the red line is a median. So knowing that's a median, we can put some like hidden givens or markings on there. So median is vertex to midpoint. If this is a midpoint, I can add that these are the same. Now I can figure out my equation. It's going to be 12a plus 12 equals 60. Subtract 12 both sides. 12a equals 48. Divided by 12, a equals 4. The question just says find a. That's good. I'm going to plug it in. Here's another one. The red line's an altitude. Altitude means the height, but means vertex and 90. All right, so if I know that's 90, again, I know these two make a linear pair together. Or you can say 99 makes 180. So I can say 15b plus 30 equals 90. I can subtract 30 both sides. 15b equals 60. Divide by 15. B equals 4. All right, red line's a perpendicular bisector. Find C, D, and E. All right, perpendicular bisector. Remember, perpendicular means 90, so this is 90. And I even draw this other one. This left side's also 90. They're both 90 both sides. So those are, and then this is a midpoint, so these two are the same. So let's find C first. That's the left side, so it's equal to the right side. So 13C minus 18 equals 34. Add 18 to both sides. 13C equals, let's see, 42, 52. Then I divide by 13. That is 4. There's a lot of 4s on this. All right, then find E. 2 E's on the left side, but it's also 90. If there's 2 spots in the same thing, they must be equal. So we'll say 2E equals 90. You can divide both sides by 2, you get E equals 45. Same for the right side. 3D is in the spot that's supposed to be 90 degrees, so they must be equal. 3D, 90 are the same thing. So 3D equals 90. Divide both sides by 3, you get D equals 30. So we found C, D, and E. All right, next, the red line is an angle bisector. Find the value P. Angle bisector means the entire angle of 80 degrees was cut into 2 equal pieces, this and this. The bottom's 3p plus 1. I know that this is also 3p plus 1. This is angle addition. Remember, part plus part equals whole, or the 2 smaller angles, or the however many small angles add to the whole thing. So I'll say 3p plus 1 plus another 3p plus 1 is supposed to equal the whole thing, which is 80. Combine like terms, that is 6p plus 2 equals 80. Subtract 2 both sides, 6p equals 78. Divided by 6, p equals 13. That's the answer. They asked me to plug it in, I could. Well, 3 times 13 is 39 plus 1 is 40. So each piece is 40. The bottom part's 40, top part's 40. Of course, 40 and 40 make 80 together. All right. Here's a challenge problem, really. Identify each special segment. So look at AH. A to H. A starts here. Vertex. And I see those 2 angle marks. That's cutting in half. And I know the end of H, there's nothing here. This doesn't say midpoint or 90 or anything. So I just know there's an angle that cut in half. That is the angle bisector. All right, so that one's done. Next one, G to C. G is right here. Notice it is the middle because you have these 2 marks right here. All right, so those 2 marks mean it's the midpoint. So we know one of the identifiers. G goes all the way to C. C is up here. That is the vertex. Midpoint vertex. That is median. All right. And let me erase these dots. All right. EF. E is right here. This is not a mid. Is it a midpoint? It is a midpoint. E is a midpoint because of these 2 marks right here. And it's 90 degrees because that box. So which one is, and if you look at F, F doesn't even go to vertex, see? So which one is 90 degrees and midpoints? That's going to be perpendicular bisector. Because perpendicular is the 90 degrees, and then bisector means midpoint. Let me draw this part back. All right, last one, CD. C is up here, is a vertex, and D goes outside the picture, but it makes 90, because if you extend this side, hopefully y'all seen this, this is like the height of its triangle. So if it's a height, that's an altitude, or vertex 90 is always altitude. Altitude. All right, there's that. All right, last slide. That's all four. Yep. There's a special note about perpendicular bisectors. So notice that the red line is perpendicular bisector because it cut this black line segment in half. That's the midpoint and has 90 degrees. So down here it says any point on the perpendicular bisector will always be equidistant. I mean the same distance from the endpoints of the bisected segment. So let's just start for here. For example, if I have a point right here, is this blue line supposed to be equal to this blue line? And the answer should be yes, because this basically makes an isosceles triangle. What if I had it up here? Should here to here be the same thing as here to here? Answer is yes, because that's supposed to be an isosceles triangle. No matter where you move on this red line, you'll always have that isosceles triangle. I could be down here. Here to here, that's not straight. Here to here is the exact same length as here to here. So like, for example, if this is 30 inches, this will also be 30 inches. All right, because notice if it's in the middle, it's already the middle of each, right? And you just move it down. So you move it down this amount, it will still be equal. Whatever this is, you can equal that. All right, so perpendicular bisectors, points on perpendicular bisectors just keep forming isosceles triangles. And if I went way down here, this, whatever this distance is to here, is the exact same as here to here. All right, make sure you understand the idea. All right, that's it for the video. Hope you enjoyed it. Make sure you ask any questions. Thanks for watching. See you soon. Bye.